Second step, hydrolysis of 2-carboethoxycyclohexanone to 2-carboxycyclohexanone followed by its decarboxylation to yield cyclohexanone. Reduction of cyclohexanone to cyclohexane. Clamshell reduction. Third step, pyrolysis of calcium or barium salt of dicarboxylic acid. Wislicenus method. Calcium, barium, or thorium salts of decarboxylic acids or heating strongly from cyclic ketones, which can be reduced either by Clemson reduction or Wolff-Kishner reduction to cycloalkanes. Wislicenus method for formation of cycloalkanes is based on Planck's rule, according to which first 1,3-dicarboxylic acid on heating undergo decarboxylation to form monocarboxylic acid. Second, 1,4 and 1,5 dicarboxylic acid on heating or distillation in the presence of acetic anhydride gives cyclic anhydride. Third, 1,6 or 1,7 dicarboxylic acids on heating or upon distillation with acetic anhydride give cyclic ketones. Fourth, 1,8 and higher dicarboxylic acid remain unaffected on heating. Now fourth, that is Damjanov rearrangement. This method provides a pathway for expansion and contraction of cyclic compounds and involves formation of carbocation as intermediate. The carbocations formed may show any of the following reaction: substitution reaction, elimination reaction, Wenger-Meerwan rearrangement. That is rearrangement to form more stable carbocation though 1,2-hydride or 1,2-alkyl shift. Example involving ring expansion and ring contraction. Ring expansion, when carboxyclobutylene methanol is treated with concentrated H2SO4 at 443 Kelvin, we get three products. Product 1 and 2 are formed through ring expansion, whereas product 3 is formed without undergoing ring expansion. Ring contraction. Damjanov rearrangement occurs through ring contraction when the carbocation intermediate has positive charge on alicyclic carbon. For example, 1-cyclobutanol undergo dehydration at 443 Kelvin to give cyclobut-1-ene as normal product and 1-cyclopropyl methanol through ring contraction.